Hello everyone, it's Mrs. Slauson, again one of the Algebra 2 teachers. We are going to be going over the Capstone review. So there's going to be two parts to this. This is version A, and then you're going to be accessing a Go formative that has version B. So there's a couple of ways you could go about this. The problems are going to pretty much match up. So question 1 on version A will match up with question 1 on version B. So one option is do all of version A and then go to Go formative and work through that. The other option is do question 1 from version A and then go to the Go formative and do question 1 for version B. So just some different thoughts. All right, so the first question is you are being asked to find the x-intercepts of the given rational function. So when you're asked to find the x-intercepts, the only part we really need to worry about is the numerator, because x-intercepts, just kind of jumping to question 4, anything along the x-axis here, that's an x-intercept. And all along that x-axis, whatever point you look at, so whether you're going to look at this point, hold on, let me switch colors here, like this point, or this point, or this point, or this point. Again, I'm over here on question 4. All x-intercepts have one value in common. They all have the value of y equals 0. So essentially what we're going to do is we're going to make f of x, which is y, equals 0. And then we are going to solve. So if you remember in the solving section, the denominator is not going to have any effect when you solve. We just have to figure out what number, if I put it in for x and do all of this math, will make my answer 0. So we're looking for this numerator to be worth 0, because 0 divided by any number in the bottom will give us 0 as our answer. The reason, again, we're not going to worry about this denominator is because, remember, you can't divide by 0. So this is why our focus is only going to be on the numerator. So I'm going to erase this real quick and start with the fact that we just need to make sure that whatever we put in for x and do the math will get us to 0. So this is a problem we're going to factor because you see more than one type or variation of x. So we're just looking for factors of negative 30 that are going to get us to 7x. And those factors are going to be a 10 and a 3. And we're going to make the 3 negative. And going to our quick version of factoring, remember the only way to get to x squared here is to multiply an x with an x. And now I'm going to use these side numbers to get the rest of my factors. So I'm going to ask myself, x times what can get me this 10x? And that would be a positive 10. And then x times what can get me this negative 3x? And that would be subtracting 3. So from there, I can set each factor equal to 0 and solve. So set this one equal to 0, add 3, and set the other one equal to 0. I'll subtract 10, and there are my two answers. Okay? All right, so at this point, maybe you want to pause and go to your Go formative and do question 1 from there. Or again, you can just go through this whole thing and then go to the Go formative. All right, number 2, this time we're going to find the vertical asymptotes. So if you remember from your graphing video, the asymptotes come from the denominator, and I realize that in this particular example, there's 2 factors in the denominator, but it's the same idea. I just want to know what would make that 0 and what would make that 0. Because remember, the denominator can never be 0. So I just want to make sure that when I graph it, the asymptote is this wall that's not going to allow your shape to touch the wall. So I would have a vertical asymptote at 3 and a vertical asymptote at negative 7. All right, so for number 3, we are going to solve. So again, the idea is when we solve, we do need to make sure that we have a common denominator between all 3 fractions. So your first goal is just to factor each denominator. So this first fraction you can't factor. You can't factor the second one, but you can factor the third one. And this is just a difference of squares. There is no greatest common factor, but this factors into x plus 5 and x minus 5. So what I'm going to do is just kind of do away with this old denominator and look at what's written in red as my new denominator. And my goal again is I want all 3 fractions to have the same denominator. So what I will need to do is to have, sorry about that, I will need my first fraction, because it has an x plus 5, it will need an x minus 5. So what I'm going to do is multiply the bottom by x minus 5. And again, whatever I do to the bottom, I do to the top. I'm going to squish it in there. My second fraction has an x minus 5, so it needs an x plus 5. So I'm going to do that next. So again, whatever I put on the bottom, I'll do to the top. And then my third fraction actually has the x plus 5 and the x minus 5, so I don't need to change that fraction. And again, once you get that common denominator, you don't need to worry about the denominator. You can let it go because your focus is only going to be in the numerator. So from my first fraction, I'll have a numerator of 3 multiplying to x minus 5. I'll have 5 multiplying to x plus 5, and put that plus up there. And the third fraction after the equal sign will just remain 8. So first I'm just going to distribute. Distribute here. Now I'm going to combine my like terms. So I'm going to have 8x. When I combine those terms, I'm going to get 10. And now my goal is to solve for x. So first I'm going to subtract the 10, and that gives me 8x on the left side and negative 2 on the right side. And then I'm going to divide by 8 and divide by 8. So what are acceptable answers on Go Formative? You can have negative 2/8. You could simplify the fraction into negative 1/4, and you could turn it into its decimal value if you'd like as well. So any of those answers when you get to Go Formative will work. All right, let's jump to number 4. So on number 4, we have to state the vertical and the horizontal asymptotes. So the vertical asymptote, remember vertical goes up and down, is always a line of x. And so when I write my answer, I'm going to want to make sure that I write x equals. And then my horizontal asymptote is a line that goes across the horizon. And this is when y equals everything. So I'm going to make sure that my answer is y equals. So again, what my students have learned is this little saying that as y flies by, x is depressed. And that's how we remember. Y flies by and x is depressed. So now I just need to put the values to them. So when I look at the x, this x is at right here. This is at negative 4. And when I look at the y, this dotted line, that is at 2. And you do have to make sure that you write your answer as x equals or y equals and then the given value. All right, number 5. Let's talk about number 5 with graphing. So the first thing I just want to talk about are the different transformations that are going to happen. So the negative here is going to be a flip. The 2 is technically a stretch. This 3 means everything is going to be going right 3, and this 5 means that everything will be shifting up 5. So for now, what we're going to do is just leave out the 3 and the 5 because this is the way we taught you guys how to graph. So we're just going to look at this. And if you remember in the video, we're looking for something, x as a value, times y as a value, gets you to negative 2. And so the idea is just coming up with those numbers. So I'm going to make this table over here. Here's my x, here's my y, because then I'm going to graph these points. So for instance, I could pick x as negative 2, and then y would have to be 1, so that when I'm done, I get negative 2 as my answer. I could pick negative 1, and negative 1 times a positive 2 is also negative 2. And then remember, you never pick 0 because this denominator isn't allowed to be 0. You can't divide by 0. I could pick a positive 1, and then y would be negative 2. And I could pick a 2, and then y would be negative 1. So I'm going to graph those points really quickly. Actually, no, I'm not going to graph those points really quickly. What I'm going to do now is put in my asymptotes. So I've got my vertical asymptote here of 3. And then I've got my horizontal asymptote up 5. And now if you just look at those as the new x and y axes, then what we'll do is from the origin right here, okay, that's not an actual point, I'll graph this point. So I'm going to go over 2 and up 1. And then this point, I'm going to go over 1 and up 2. And here's one shape. Didn't do very well, kind of crossed that vertical asymptote. And then for this one, I'm going to go right 1 and down 2. And then I will go over 2, down 1, and I will get this shape. Okay, so just a little review on graphing. Problem 6, the job is to list the transformations. So again, just talking about the transformations, I'm going to have a flip. A little bit more specifically, it's going to flip over or across the x-axis. This 4 is going to stretch. The 2 is going to go right 2, and the 5 is going to make the shape go up 5. All right, our last set of problems. So I think the order I'm going to go is I'll do 7 and 8. Those are pretty similar. Well, I'll do 7 and 8 because they're in order. So when I simplify, again, what I need to do is make sure I factor the numerator and the denominator. So I'm actually going to start as the denominator because I think that's the easiest part. I'm going to factor out a GCF. That's always your first step. I can take an 8 out, and then I'm left with x plus 4. And then as far as x plus 4 goes, I can't factor that anymore. And then I'm going to go to my numerator and look for a GCF. I don't see one, but with 3 terms, I'm going to make my x. So I need factors of negative 12 that get me to 11, and those are going to be a 1x and a 12x, and I want to make sure that the 1 is negative. So now I'm going to go to my parentheses. And again, the only way to get to 3x squared is to multiply a 3x with an x. And so now I'm going to use my x that I made, these side numbers, and I'm going to ask myself, all right, can I take 3x times something to get to this negative 1x? No. But I can take 3x times 4 to get to that 12x, so I'll put a plus 4 there. So that takes care of this one. So that means I'll have to use x times a negative 1 to get this negative 1x, and then that takes care of that one. So now I just want to look for those common factors between the top, the numerator, and the bottom. And those common factors are an x plus 4 and an x plus 4. So when you're done, 3x minus 1 over 8. Okay. All right, number 8, I'm going to do the same thing. I just have a little bit more to try to factor. So first I'm going to start with my first fraction. I'm going to factor 2x plus 6. Again, I always start with the GCF. I can take out a 2, and I get an x plus 3 when I'm done. And then I'm going to factor the denominator. So again, I look for a GCF. I don't see one, but with 3 terms, I'll make my x. So I need factors of negative 5. They get me to 4. That's going to be a 1x and a 5x, and I'll make the 1 negative. And so now going to my parentheses, again, the only way to get to this x squared is to multiply an x with an x, and now I use these side numbers to help me get the rest of my factors. So can I take x times something to get to negative 1x? I can, it's negative 1. And then can I take x times something to get to 5x? I can, and that's a positive 5. So when I go to my second fraction, I notice I cannot factor x minus 1. There's nothing I can do. But I will wrap it in parentheses. And then the 10. I am actually going to factor out the 10 so you can see this a little bit easier. If I make a factor tree of 10, because then it'll show me factors, I can get 2 and 5. So I'm going to break this down into 2 and 5. So now what I want to look for, are there any common factors between the numerators and the denominators that I can cancel out? So we'll start with the obvious one, the x minus 1s, but then I can also factor out the 2 because those are also factors. So when I'm done, my answer is going to be 2 with x plus 3, and then my denominator is going to be a 5 in front with x plus 5. And you can leave your answer like that. If you do want to distribute your 2 in and write your answer like this, you can do that as well. So sorry, that's my dog in the background. All right, so last one on number 8. So number 8, hopefully you're definitely watching this video, but with this subtraction, when you tend to add or subtract these rational expressions and there is subtraction, not everyone gets it right because of the subtraction that's in between them. So what I'm going to do first is turn it into addition. And so I'm going to add, And then I'm going to take the opposite, and I'm going to take it to the numerator, which means I will be taking the opposite of x, and I'll distribute it to the other term and make the 2 a -2. So now I'm ready to add or subtract them. So again, whenever you need to add or subtract fractions, you need a common denominator. Lucky for us, they already have that. So my denominator will just be x - 3 as we go along, because the denominator just goes along for the ride whenever you add or subtract. And I'm going to add up my numerators. So here's just the whole numerator written out right now. And then I will combine my like terms. I'll combine these x's and get 4x. I'll take -2 with this -2 and get a -4. So this is a great answer. If you want to change it anyway, you could take a 4 out of the numerator and have this as your answer, but you don't need to do that. That's up to you. As far as simplifying from there, I can't simplify anything. There are not common factors. So again, don't be mistaken and think that you can take this x out and this x out, because those x's are in terms. So factors are what's multiplied. All right, last problem. So this is where I talk about making the house, if you've ever been in my class. So first of all, with division, I will copy, and I will dot, and I will flops. So I'm going to flip-flop the second fraction. And so what I like to do here is just to, instead of kind of this one big messy problem, make 3 smaller problems. So the first thing I'm going to do is what I call make the houses. So I'm going to put these coefficients, the 7 and 21, in the first house. So 7 on top, 21 on the bottom. And then I'm going to put my x's in a house. So x squared and x to the 5th, and then another x to the 5th. And they're all going to go right where they are. So x squared will go on top, the 2x to the 5ths will go on the bottom, and then I'll put my y's in their house. So let's start with the easiest one. It's probably the y's. When you're ready to simplify the y's, remember you just subtract those exponents. So I'll have y squared on top. When I get to the next one, just down here, I could actually just make that x to the 10th instead. And then I'm going to subtract these exponents, and I'm going to have 8 x's on the bottom, because remember, there are more x's to start out with, so when they do cancel out, that's where the leftovers will be. And then don't forget to simplify this fraction. You're not going to subtract because these aren't exponents. You're just simplifying this fraction. So divide the top by 7, divide the bottom by 7, and you get 1/3. You don't technically need 1 in the answer, but you're welcome to have it. And that's it. So now you've got your go formative.